Good morning, dear students. Today we are going to study a new lesson, and it's, by the way, the last lesson in calculus this year. This lesson is called integration, and it's a new term, a new thing that we will learn in calculus, integration. And by the way, it's a very, very important thing to learn in calculus. It will help you really in third secondary. Okay, let's start. Integration. First, what's the meaning of integration? Integration means that it's an inverse operation for differentiation. Differentiation, we already have been have been taken from the previous lessons. All the semester we already studied differentiation in details and know actually very well the meaning of differentiation. In a simple word, integration is the inverse operation of differentiation. For example, if I have a function f of x equals, for example, x power 3 plus 5x power 2 plus 6x plus 7. This function, if I want to find the first derivative of this function in terms of x, so I will find d by dx for f of x. To find the first derivative, it will equal 3x x power 3, it will be 3x power 2. 5x power 2, it will be 10x plus 6x, the derivative of 6x is 6, and 7, the derivative of 7 is 0. So it's simple, and already we solved many examples like this to find the first derivative of a given function. But now we are going to make an inverse operation. We already have a derivative for a function, and we need the original function. So we need an inverse operation from the derivative to get the original function. By the way, we have some terms. This is a function, and here we make differentiation to find the first derivative. So this expression represents for me that it's the first derivative of the given function. But now I have the derivative and I need the original function. So this function is called antiderivative for f dash of x. Yani this is the antiderivative of this expression. So this is the derivative of the given function, and this is the antiderivative of the given derivative. So this is the meaning of integration. So if you have a function and you find the first derivative, you make a differentiation. And if you have the first derivative and you need to find the antiderivative of this expression, you have to make an integration. And this integration can be expressed as integration and this sign, integration of 3x power 2 plus 10x plus 6. I will make an integration for this expression, all this expression in terms of dx. Which means that I will make an integration for this expression in terms of x, which means that x is the main variable for this integration. So the 3x power 2, the antiderivative of 3x power 2 will be x power 3, and we will learn how to find this integration later. Plus 10x, the antiderivative of 10x is 5x power 2. Plus 6, the antiderivative of 6 is 6x, and we consider that there is a term, one more term, which is equal plus 0, and this term is a derivative for a constant. So I expect that there is a constant here, which is called c, but I don't actually or exactly know the value of this constant. So I write instead of 7, because I don't know that its value is 7, I write instead of 7 c. And it's very important, and don't forget this constant, because your integration will be not complete. So this operation I did is called integration, simply. And the problem now is how to find this antiderivatives, or how to make an integration process. Will I predict that 3x power 2 is its antiderivative is x power 3? I need a certain process or a certain rule to find the integration of a given function. So we will put two main rules to find this this antiderivative, or to make an integration process. The first rule. Let's move to another page. The first rule is integration of x power n for the x. It will be, if I need to make an integration for x power n with respect to x, can you remember how can I find the derivative of a given function in this form? For example, x power 5, it will be 5, so I will multiply the power by the coefficient here, 5 times 1, which is equal to 5, times x power, and I reduce the power by 1, so it will be 4. So 5x power 4 equals x power 5. To make an antiderivative for this function, I increase the power. Here I multiply by the power and reduce 1 or subtract 1 from the power. In the antiderivative, to find the antiderivative, I make an inverse operation for all these operations. So I will increase the power by 1 plus 1, and I will divide by the new power, which is 5. So 5 will cancel with 5, and it will be x power 5. So I found finally the antiderivative for x power 4. So when I have a function x power n for the x, or with respect to the x, if I want to find the integration of this, it will be x power n plus 1. So I will increase the power by 1, or add 1 to the power, and divide by the new power over n plus 1, and don't forget plus c. For example, integration x power 6 with respect to the x. It will be, I will increase the power by 1, so it will be x power 7, and I will divide by the new power, it will be over 7 plus c. This is the antiderivative, or it's the original function that I have the derivative here. This is the first rule, so it will be rule number 1. Rule number 2, if I have not a parameter or a variable x, only if I have a function f of x, a whole function or a whole expression, and this expression has a power on it. So to find the antiderivative with respect to x, or to make an integration with respect to x, you should first make sure that this function, its derivative is multiplied here by the bracket. So to find how to make an integration for this function completely or perfectly, you should make sure that this function, the derivative of this function is multiplied by here. So here must be f dash of x. Then we will follow the same rule. You will increase the power by 1 and divide by the newer power. So it will be f of x whole power n plus 1, and divide by the new power n plus 1 plus and don't forget C plus constant. So again, make sure that the given function inside the bracket, its derivative must be multiplied by the bracket. Make sure that its derivative must be multiplied by the bracket again. And don't forget this rule. So for example, if I have integration 2x plus 5 whole power 3, and here is 2 dx. So this will be equal. The base here is a term or a whole expression or a whole function. As you will answer sure. The base here is a whole expression 2x plus 5. So I have to make sure that the derivative of this expression is multiplied by the bracket. So here, yes, the derivative of 2x is 2 and the derivative of 5 is 0. So the derivative of the whole expression is 2 and it's multiplied by the bracket. So I will follow the rule easily. It will be 2x plus 5 whole power 4 and divide by the new power, which is 4, and plus C, don't forget. To make sure that you are solve it right, try to find the derivative of this function 2x plus 5 whole power 4 over 4 plus constant. If I want to find the first derivative of this, I will multiply it by 4, so it will be 4 2x plus 5 power 3 over 4, and then times the derivative of the bracket, it will be 2 plus constant, which its derivative is 0. By simplifying this expression, 4 will be cancelled with 4, 4 divided by 4 equals 1, so the expression will be 2x plus 3 whole power 3 times 2 beside the bracket, which is the derivative given in the integration process. So I here found the antiderivative of this expression. Let's move to examples. Okay, let's start solving some examples and what we have already taken. And remember that when I want to integrate a term like this with respect to x, I have to increase the power and divide by the new power. So let's start. For example 3a. I want to integrate x power 5 with respect to dx, which is equal to, here I have to ask myself a question, an important question. The base here is x, so the derivative of x is 1, so there is no need to multiply here by 1. So the antiderivative or the integration of x power 5 will be x power 6 over the new power, which is 6, and don't forget plus c. And it can be written in the form of 1 over 6 x power 6 plus c. B, integration x power negative 3 dx. This equals to, let's ask the same question. The base here is x, so the derivative of x is 1, and it's not important to multiply it by 1. So x power negative 3, its integration, it will be x power negative 3 plus 1, it will be equal negative 2. And we'll divide by the new power, which is negative 2, and plus c finally, which is maybe can be written as negative 1 over 2 x power negative 2 plus c, or it can be written as negative 1 over 2 x power 2 plus c. Third question, c, integration x power 2 over 5 dx. The same question. X here's only x. The derivative is 1, so it's no need to multiply it by 1. To be multiplied by 1. So the integration will be x power 2 over 5 plus 1. It will be 7 over 5. And multiplied by the new power, which is over 7 over 5. And plus c finally, which can be written as, when I divide by 7 over 5, it can be written as x power 7 over 5, as it is, and we'll multiply it by 5 over 7, which is the multiplicative inverse of 7 over 5. So when I divide by a fraction, I can multiply it by the multiplicative inverse of the fraction, and plus c finally. The last question, D. Integration of 1 over 5th root x power 3 for by dx, which is equal to, it can be written in more simple way or in a simplest form. It will be integration 1 over x power 3 over 5. As you learned from the last year or previous years, when I want to write it in the form of an exponent, it can be written as x power 3 divided by the degree of the root, which is 5. So it will be x power 3 over 5 dx. And also can be written as integration x power negative 3 over 5 dx. So when I want to find the integration of this, the derivative of x is 1. So I will increase the power 1 and divide by the new power, which is x power negative 3 over 5 plus 1. I will add here negative 3 over 5. I will add plus 1 to it. Negative 3 over 5 plus 1, it will be 2 over 5. And I will divide by the new power, which is 2 over 5. And plus c, which can be written as, finally in the simplest form, can be written as 5 over 2 x power 2 over 5 plus c. And remember to make sure or to test your answer, is it right or wrong, find the first derivative of the answer. It will give you the original integration or the original antiderivative. So let's move to another example.
But before we start, before resuming solving examples, we have to discuss some properties of integration to use it in solving problems, different problems. The first one is, if I have integration a times any given function, so here a is a constant and not equal 0. So I can put a outside the integration, or I can exclude a from the integration. So it will be, for example, absolute integration 5x power 2 dx. It can be written as equals 5 integration x power 2 dx. Because 5 is constant, so it's not effective, or it has no any effect on the integration. So I can put it outside the integration. So 5 integration x power 2 plus dx, which is equal to 5 times the integration of x power 2 will be x power 3 over 3 plus c finally, which is equal to, can be written as 5 over 3 x power 3 plus c. And also the second property that that we can discuss is integration of f of x plus or minus r of x if I have many functions added to each others, or not subtracted from each others. So I can distribute the integration with f of x and r of x, which can be expressed as, in this example, integration x power 3 plus 3x power 2 plus for dx for the whole function. So as I see here, we have three terms are added to each other, or I can consider them as three functions added to each other, adding or subtracting, plus or minus. It's not a big matter here. So I will distribute integration within the three terms, so it can be written as integration x power 3 dx plus integration 3x power 2 dx plus integration of 4 dx. And here is integration of x power 3, it will be x power 4 over 4 plus, and here is plus c, don't forget. And also here the 3x power 2, it will be 3x power 3 over 3, and also plus c, plus 4x, and also plus c. And we can include all the constant here in one constant, so it will be x power 4 over 4 plus x power 3, because 3 will be cancelled with 3, plus 4x, and finally plus a constant which is including the sum of the C1 and C2 and C3. All the constants, I will add them to each others to give a bigger constant, and a final constant in the problem. So how can I use these properties to solve more or harder questions? Let's see another question. Okay, in this example, I have integration, letter A, integration of 2 plus root x plus 1 over root x dx. So I can distribute the integration on the three terms, the three given terms. So it can be written as integration of 2 for the x plus integration for root x dx plus integration for 1 over root x dx. And this is equal to integration 2 dx plus, this can be written as x power half, so it can be written as x power half dx plus this can be written as x power half, but if I want to write it in the numerator, I will write it as x power negative half dx. And let's do the integration. 2 is a constant, so I can write it outside the integration, so it can be 2, and here instead of 2 will be 1. The integration of 1 is x. As you know that x, its derivative is 1, so 1, its antiderivative is x. Plus this will add, we will add 1 plus half, it will be here, we will add 1, and here also we will add 1, and we will divide by the new power, so it will be x power 3 over 2 over 3 over 2 plus x power negative half plus 1, it will be half over half. All this plus a big constant which includes all the constants from the small integrations. So it will be in the final form 2x plus dividing by 3 over 2, it means multiplying by 2 over 3. 2 over 3 x power 3 over 2 plus 2x power half plus constant. The second example can be written as 1 over x power 2 can be written as x power negative 2, and root x can be written as x power half. So the integration will be integration of x power negative 2 dx plus integration of x power half dx plus integration of 3 dx. The first one, the integration of x power negative 2, and I will remind you that every time you have to ask yourself the derivative of the base x here, its derivative is 1. So it's not important to be multiplied here by 1. But if the base is otherwise, you have to, the function must be multiplied by its derivative beside it. So the derivative of this, the integration of x power -2, we will add 1 here, plus 1, and divide by, and also here, and we will divide by the Nouh power, and it will be x power -1 over -1, plus x power 3 over 2 over 3 over 2, plus 3x, and finally plus a big constant which includes all the constants resulted from the small integrations. So this can be written as, in the simplest form, -x power -1 plus 2 over 3 x power 3 over 2 plus 3x plus c, or it can be written as -1 over x, because x power -1 can be written in the denominator x power 1, plus 2 over 3, and x power 3 over 2 means x power 3 under the square root, so it can be written as 2 square root x power 3 plus 3x plus c. And to make sure that you are solving right, you have to find the derivative of this expression. It will give you the first expression given in the integration. Let's move to another example. And to test your understanding, please pause the video and solve these examples to just test your understanding for the lesson. Take 5 minutes to solve this and resume the video. And now again, after solving the equation, the integrations, revise your answers with the answers I will give you now. First, A, the integration of x power 8 dx, it will be equal to x power 9 over 9 plus c, which can be written as 1 over 9 x power 9 plus c. The second one is B. Also, I will add 1 and will divide by the Nouh power, which is x power 5 over 3 over 5 over 3 plus c, or it can be written as 3 over 5 times x power 5 over 3. It means x power 5 under a cube root plus c. Integration of x power 5 over 7 plus c, it can be dx, it can be equal x power 12 over 5 over 12 over 5 plus c, or it can be written as 5 over 12 x power 12 over 5 plus c. The final one is I can exclude 7 from the integration because it's constant, and the constant multiplied by the function, and there is no importance here for it. So d can be written as 7 integration x power 7 over 9 dx, which is equal to 7. I will add 1 to the power. It will be x power 16 over 9 over 9 over 16, which is equal to finally divided by 16 over 9, which is the Nouh power, and plus c, which is equal to 7 times 9 over 16 times x power 16 over 9 plus c, which is finally equals 63 over 16 x power 16 over 9 plus c. Let's move to another example.